From the deepest reaches of the cosmos, a visitor has arrived. Not an alien craft, but something far more ancient and mysterious. A comet, hurling through the void for billions of years, is now making its grand entrance into our solar system. We call it Oumuamua, a Hawaiian name meaning a messenger from afar arriving first. But this was no ordinary comet. Its shape was bizarre, a long, thin cigar, unlike any celestial body we had ever seen. And its trajectory was even stranger. It didn't just passively fall towards the sun. It accelerated away, as if propelled by an unseen force. What was this object? A natural phenomenon we've yet to understand, or something else entirely? The mystery of Oumuamua ignited a fire in the scientific community. Could it be a piece of alien technology? A derelict solar sail, pushed by the gentle pressure of starlight? The idea, proposed by esteemed astrophysicist Avi Loeb, was controversial, but it forced us to confront a profound question. Are we alone? This question has echoed through human history, from ancient myths to modern science fiction. We spent decades scanning the skies with radio telescopes, listening for a whisper from the stars, a sign that another intelligence shares this vast universe with us. This is the story of that search, the story of our quest to find our place among the cosmos. Imagine a civilization far more advanced than our own, one that has mastered interstellar travel. What would their technology look like? According to the Kardashev scale, a Type 1 civilization can harness all the energy of its home planet. A Type 2 can control its star, perhaps by building a Dyson sphere, a megastructure that completely encloses it to capture every bit of its energy. And a Type 3 civilization? They will command the power of an entire galaxy. We on Earth are not even a Type 1 civilization yet. We're still taking our first steps, learning to walk before we can run. So, if a Type 2 or 3 civilization exists, their technology would seem like magic to us. Oumuamua, with its strange acceleration, could have been a probe from such a civilization, a piece of technology so advanced that it defies our current understanding of physics. The force that propelled Oumuamua remains a puzzle. The leading natural explanation is outgassing ice on the comet's surface, turning the gas when heated by the sun, acting like a tiny rocket engine. But we saw no evidence of this gas, no telltale coma or tail that accompanies every other comet we've observed. This absence is what makes the alien technology hypothesis so compelling. A solar sail, a thin reflective sheet pushed by photons from the sun, would accelerate in exactly the way Oumuamua did, without any visible exhaust. It's an elegant, efficient way to travel between stars, a technology we ourselves are developing. Did we just witness a piece of a galactic transportation network humming along right through our backyard? But let's step back from the specific case of Oumuamua and look at the bigger picture. The universe is unbelievably vast. There are hundreds of billions of galaxies, each with hundreds of billions of stars. And we now know that most of those stars have planets. With such staggering numbers, it seems statistically inevitable that life, and even intelligent life, must exist elsewhere. This is the heart of the Fermi paradox. If aliens are so likely, where is everybody? Why is the cosmos so silent? There are many potential answers. Perhaps civilizations are too far apart in space and time to ever meet. Maybe they destroy themselves before they can achieve interstellar travel. Or perhaps they are out there, but they are deliberately hiding from us, observing us from a distance, following a kind of prime directive, not to interfere with emerging civilizations. Let's consider that last possibility. If a hyper-advanced civilization is watching us, what would they see? A species full of contradictions. We compose breathtaking symphonies and write profound poetry, yet we also wage brutal wars. We build telescopes to gaze at distant galaxies, yet we struggle to take care of our own planet. Maybe they are waiting for us to overcome our self-destructive tendencies, to mature as a species. Perhaps contact is a prize to be earned, not a gift to be given. Oumuamua, in this context, might not have been a message, but a test. A subtle clue left for a young species to find, to see if we were paying attention, to see if we were ready to ask the bigger questions. The search for extraterrestrial intelligence, or SETI, is our attempt to answer these questions. For over 60 years, we've used massive radio dishes, like the one at Arecibo or China's Fast Telescope, to listen for artificial signals from the stars. It's like searching for a single needle in a haystack the size of the cosmos. So far, the great silence has prevailed. But the absence of evidence is not evidence of absence. We have only scanned a minuscule fraction of the sky for a limited range of signal types. Our search has just begun. New projects, like the Galileo project led by Avi Loeb, are shifting the focus. Instead of just listening, they aim to actively search for physical artifacts, for Oumuamua and other technological signatures of alien life right here in our solar system. Metaphysics enters the conversation when we contemplate the nature of a consciousness that could create such technologies. They might not communicate with radio waves, but through methods we can't even imagine, like gravitational waves or even manipulations of space-time itself. We might be surrounded by their signals, their presence, but be completely unable to perceive it, like an ant crawling on a superhighway, unaware of the complex world just inches above it. This brings us back to the comet, to the physics of these icy wanderers. Comets are time capsules, formed in the cold, outer reaches of a solar system. They are pristine remnants from the birth of stars and planets. By studying their composition, we learn about the building blocks of life, amino acids and organic molecules which we found on comets in our own solar system. This suggests that the ingredients for life are not unique to Earth. Comets could be cosmic delivery systems, seeding planets across the galaxy with the potential for life. Oumuamua was an interstellar comet, the first we've ever seen. Studying such objects could tell us if the building blocks of life from other star systems are similar to our own. Are we all made of the same star stuff? The legacy of Oumuamua is not that it proved aliens exist. It didn't. Its legacy is that it shattered our complacency. It reminded us that the universe is full of surprises and that we should be prepared for the unexpected. It legitimized the scientific search for technological signatures. It opened our minds to the possibility that the first sign of intelligent life won't be a friendly hello on the radio, but a strange object silently tumbling through our solar system, a messenger from afar that challenges everything we thought we knew. The search continues, fueled by curiosity and the eternal human desire to know our place in the universe. One day, we may find an answer. We just need to keep looking up. Thanks for watching.